All right, so tonight's notes are on accuracy versus precision. We usually use these terms when we're talking about measurements. So we're going to figure out what it means for a measurement to be accurate versus measurements to be precise. Okay, and then we're also going to talk about one more concept called percent error, but it's pretty easy. So these notes should be pretty short and sweet. All right, let's get started. All right, so our first question is, what does it mean to be accurate versus precise? So we'll start with accuracy first. The definition of accuracy is how close a measurement is to the accepted or the actual measurement of whatever you're measuring. Okay, so if you are measuring, 1 cup of water, all right, it's, how accurate, how close can you get to that 1 cup of water, that 1 cup little tick mark there on the cup. How close can you get is how accurate you will be. Now precision has to do with how close repeated measurements are to each other. So if you've only measured something once in an experiment, okay, you might be accurate, okay, but can you repeat those results? And that is, one of the major things you have to do when you're doing experiments and you're trying to discover something new. You have to prove to somebody else that you have done this, a lot of times, and you get the same result every time. That is what brings something from a theory into law, is to be able to be precise in your measurements. To be able to repeat them and get close to or exactly the same answer every time. So that's what precision means. Now let me show you guys a picture of the two, and we'll kind of discuss that. Okay, so if we take a look at these 4 pictures, all right, one of the most prominent way that people kind of figure out the difference between accuracy versus precision is through archery, or like target practice. So here we've got a target. Now, to be accurate on a target, we want to get the middle, all right, in the middle. So that's what we're going to call accurate. And if we take a look at this first target practice here, we see that all of the arrows are in the target spot, okay, and there's 3 of them that are all in the target spot. So this scenario here is accurate because all of them are right, where they should be in the middle, and all of them are right next to each other. We were able to repeat that same accuracy every time. So number 1 is both accurate and precise. Okay. Now in the second scenario here, we've got some arrows, and they're all pretty close to the middle, okay? But they're not all exactly next to each other, okay? So in this scenario, we will see that it is pretty accurate, okay? We can call them accurate. They're all touching at least the targeted red center, but they're not very precise, okay? We've got one here, we've got one over here, we've got one over here. They're kind of all over the place, surrounding that red target circle. Okay, so this is accurate but not precise. All right. Now, if we take a look at the third scenario here, okay, this one, again, we see all of the arrows clustered together. Okay, that's good in precision. All right, so whatever, each time we were able to repeat the same results. However, they missed the target, okay? They did not get the target at all. So in this scenario, all of the arrows are precise. They're next to each other, okay? But they're not accurate because they didn't hit the red part, the red target at all, okay? Now, number 4, okay, is neither accurate nor precise, because if we take a look, they all missed the red target, and they're all over the place, okay? We've got one on the blue, on the yellow, and on the white, okay, parts of the target. So they are not accurate because they didn't hit the red part at all, and they're not precise because they're not, anywhere kind of near each other, all right? So that's kind of the difference, between accuracy and versus precision, okay? Accuracy, how close a measurement is to the actual, accepted value. And precision is, okay, how close can your repeated measurements be to each other? If they're very close to each other every single time, you can call that precise, okay? If you do something over and over again and it's all over the place, that's not very precise, and you're going to want to, either you're going to want to, change what you're doing a little bit to get better results, okay? So that's kind of how we're going to work with it in science. Usually in our measurements is when, we're going to talk about accuracy versus precision. In fact, we're going to relate this accuracy and precision to the different instruments we're going to be using in chemistry. Okay, so let's take a look. So if we're in chemistry class and we are using, beakers, all right, this is the beaker versus graduated cylinders here, we can see that the graduated cylinder has more markings along the side here than the beaker. Okay, so for example, this beaker has got a line, assuming it's 25, 50, 75, 100, 125, 150, okay, where the graduated cylinder on the right has, 1, 2, 3, 4, 5, 6, all the way up to 50, okay, so the more markings that you have on your instrument, the more, precise, or how close to each other multiple measurements will be, and the more accurate your results will be, okay? Because you'll be like, spot on. It's 32.5 milliliters, okay? Rather than if you've got the same amount in the beaker, you're like, well, it's 30 something, okay? So again, the more markings you have, the more precise and accurate your measurements will be. And finally, referring to significant figures and what we've talked about with those, the more sig figs that are reported in a measurement, the more precise and accurate that measurement is. Okay, so the more digits that you have, rather than just 100 milliliters, if you had 100.50, okay, that is definitely more precise and accurate than just 100 milliliters. All right, so just those two kind of things to keep in mind as we're talking about measurements and accuracy versus precision. All right, so we're going to take a look at our second and final question for these notes, and let's take a look. So our second question is, what is percent error in an experiment? We're going to be doing lots of experiments this year in chemistry. And you're going to be expected, to reach a certain, amount of product in your experiment. And if you don't reach that much, okay, then, that difference in how much you got versus how much you should have got is what we call a percent error. So let's take a look at the details. All right, so again, it's the ratio of how much product you got during an experiment versus how much you should have gotten. So what this does is that it gives you an idea of how much error occurred during the experiment, how much went wrong. So for example, if you're supposed to get 100 grams of product, okay, in the end, and you got 60 grams of product in the end, all right, that's a 40% error, all right, it's pretty big. Because your 60 grams is nowhere near the 100 grams you should have gotten. Okay, so that means that something went wrong. Okay, and actually a lot of something went wrong in the experiment. So whenever we're taking a look at percent error, it's going to help us kind of pinpoint and discuss what went wrong in the experiment. Okay, now if you ended up with 95 grams out of the 100 grams you were supposed to have, then your percent error is really low, only 5%. And so that means that you did everything spot on right. There was little error in the experiment, and everything was good. Okay, so that was a good experiment. So let's take a look. There's actually a equation that we're going to use for percent error. Now let's write it down, and I'll walk you through it. All right, so here is the equation for calculating the percent error in your experiment. Okay, so we're going to be dealing with the measured value. Okay, so that's what you got. Okay, and you're going to subtract that from the accepted value, what you should have gotten. Okay, so that's what you should get. And then you're going to take the absolute value of that. Okay, so these bars over here means absolute value. Okay, so if the measured value minus the accepted value ends up being a negative number, okay, you're going to take the absolute value of that, meaning that you're going to ignore the negative, all right, and just take that value, all right. So you're going to do measured value minus accepted value, okay, and then you're going to divide, all right, by the accepted value. Again, the accepted value is what you should get in the experiment, okay, or what you should have gotten in the experiment. Okay, and then once you've got that number, you're going to, last but not least, okay, multiply it by 1,000, or not 1,000, 100. Okay, multiply it by 100 to get the actual percent. Okay, so one more time, the measured value minus the accepted value, the absolute value of that. Okay, so if it ends up being a negative number, ignore the negative. Okay, and then you're going to divide that by, again, the accepted value, times it by 100, and that's going to give your percent error. All right, so tomorrow in class we're going to have some practice problems. Okay, where you'll be given, you should have got this much, but you ended up getting this much. What was your percent error, kind of thing? Okay, so you'll be working with these kinds of problems in a few example problems tomorrow in class. So make sure you guys kind of understand that. Otherwise, that is it, and we'll see you tomorrow.